concrete को chapter number 7 design of masonry structure को भिडियो बनाउँदैछु सो कन्टेन्टहरु यस्तो छ 7.1 मा छ design of masonry in compression 7.2 मा छ design of masonry in bearing 7.3 मा छ design of masonry in bending 7.4 मा छ design of masonry in shear 7.5 मा छ design and detailing of reinforced masonry structure. Types of wall: axially loaded wall, eccentrically loaded wall. Axially loaded wall, line of action of load on the wall is acting at the center of wall. Eccentricity is 0. Eccentrically loaded wall, line of action of load on the wall is acting at other than the center of wall. Eccentricity and moment is developed. Design of axially loaded wall steps. Step number 1, selection of wall thickness T based on the availability of masonry dimension and other general requirement for wall security, temperature, humidity, etc. Step number 2, calculation of effective area A of wall. Step number 3, calculation of total weight P at the critical section of wall. This includes self weight of the wall and other imposed load. Step number 4, calculation of compressive stress sigma C due to total axial load at critical section of wall. Step number 5, calculation of stiffening coefficient Kn of wall based on the ratios SP by WP and TP by TW from table 6. Step number 6, calculation of effective thickness TE of wall based on the type of wall, solid wall, cavity wall, wall with piers, buttresses, cross wall, etc. TE को value T निकाल्ने formula Kn into T. Step number 7, calculation of effective height HE and effective length LE of wall based on its end condition and center to center support distance along height and length. Table number 4 and table number 5. Calculation of slenderness ratio SR and check as per table 7. SR भनेको HE by TE or LE by TE which is smaller. Step number 9, consideration or calculation of eccentrically. Step number 9, consideration or calculation of eccentricity to effective thickness ratio E by TE. Step number 10, calculation or selection of stress reduction factor KS due to slenderness ratio and eccentricity from table number 9. Step number 11, selection of the type of masonry unit and mortar type and selection of basic compressive strength FCK of masonry from table 8. Step number 12, calculation of allowable compressive stress sigma AL of wall as per CL 5.4. Sigma AL भनेको KS into K into KP into FCK. Step number 13, comparison of axial compressive stress and allowable compressive stress for safety. For safe condition, allowable stress will be greater or equal to axial stress, that is sigma L is greater or equal to sigma C. यो चाहिँ अब एक्जाम्पलहरु भयो, यसको चाहिँ म नेक्स्ट भिडियोमा ल्याउँछु है त. सो यो चाहिँ क्वेशनहरु मात्र हो. Concentrated load clause 5.3.1. Clause 5.3.1, the angle of dispersion of particle load on walls is 30 degrees from vertical. Clause 5.4.1.5, a load is taken to be concentrated when area of supporting wall equals or exceeds 3 times the bearing area. Work out as per the best judgment of the designer. Appendix C2, the permissible bearing stress is 50% more than the compressive stress of masonry when concentrated load bears not wider than half the thickness of wall. The permissible bearing stress is 25% more than the compressive stress of masonry when concentrated load bears full thickness of wall. Examples: concentrated load. Wall with opening. A wall with opening is considered separately because the net cross-sectional area available to resist the load at the level of opening is reduced and there is change in slenderness ratio. Cross-sectional area. Minimum area available under the load is considered as the critical or net area. This is equal to the cross area minus the area of opening, that is area equal to L minus capital L minus small l divided into T. Slenderness ratio. This is the ratio of effective height to the average effective thickness. The average effective thickness is the average of two quantities: effective thickness at opening level and above opening. Effective thickness at opening level T भनेको L minus I into T divided by L. Above the level of the opening, effective thickness of wall is equal to its actual thickness T. The average effective thickness TWE भनेको T plus T divided by 2. TWE भनेको L minus I T divided by L plus T divided by 2. Slenderness ratio भनेको SR भनेको HE by TWE or LE by TWE. The design requirement is still the same, that is compressive stress developed should be less than the allowable compressive stress. यो examples wall with opening को लागि हो. Cavity wall clause for 4.5.4 and 4.5.5. Effective thickness of wall T भनेको 2/3 into TEI plus TEO. TEI भनेको effective thickness of inner leaf, K1 into TI. TI भनेको thickness of inner leaf wall. TEO भनेको effective thickness of outer leaf, K1 into T0. T0 भनेको thickness of outer leaf wall. यो भनेको पनि एक्जाम्पलै हो क्याभिटी वालको. सो यिनीहरू चाहिँ म छुट्टै भिडियो बनाउँछु न्युमेरिकलको लागि चाहिँ. सो आजको लागि पनि कन्टेन्ट यति नै थियो. सो थ्याङ्क यू.